So this video tutorial looks at the mathematical strand of number, and more specifically we're going to focus on inverse proportion. Okay, so what is inverse proportion? Well, basically inverse proportion means that as one variable gets bigger by a certain constant, the other gets smaller by that same constant or same amount. As you can see in the green box, okay, two variables are inversely proportional or vary inversely when one is multiplied and the other is divided by the same amount. All right, and we can see that the formula here is very similar to our direct proportion, except that we have a divide instead of a times. Okay, and when you graph these two variables, all right, you can see that if we graphed x versus y, okay, then we wouldn't get a straight line. But if we graph 1 over x and y, all right, then that's going to give us our straight line, just like we should have in direct proportion. Okay, so let's see an example question. The question says, consider the table below. By plotting y against 1 over x, determine if y is inversely proportional to x. Well, the first thing I want to do is I want to create a new table, okay, which doesn't have x and y on it. What it does have is 1 over x and y. Now y is obviously going to stay the same, 40, 20, 10, 5, okay, but 1 over x becomes 1 over 1, this becomes 1 over 2, this becomes 1 over 4, this becomes 1 over 8. So now along our x-axis I need to go from a value of 1 back down to 0. Alright, so let's say we go so that can be 1 whole. We know that 1 half is here. Alright, there's 1 whole, 2 would be out here. On the y-axis, I'm going to make a scale so that I can fit everything on. And let's go up by, alright, there's our value for x and y. I'm now going to plot these points, and hopefully I should get a bit of a straight line. 1 and 40 will be up here somewhere. Half and 20 will be here. Quarter and 10 will be here. And 1, 8 and 5 would be here. Okay, so we can see that this is going to be coming down straight through there, and it's not a very good straight line that I've drawn, but you can see that they are inversely proportional because there's a straight line that's come through. Okay, so here's another example question, and just like in direct proportion, okay, we can still use a formula or a multiplier. I'll show you the formula first for question A, and then I'll show you the multiplier. Alright, so if we're going to use a formula, we can say that m is proportional to 1 over t, therefore m equals k over t, and I can substitute my m value and my t value in, and go, therefore 200 must equal k over 3, and I can say therefore k must equal 600. Now I can substitute back in, or k back in, to find out m. So therefore m must equal 600 over 5. Remember when we're looking at t equals 5, so this is now question A. Therefore m must be 120. Now if I want to use the multiplier, I can say for t, yeah, 3, okay, so 200 to 3 is the same as m to 5. Now to turn 5 into 3, 3 into 5, I've got to times by 5 over 3. Now because this is inversely proportion, I'm now going to times 200 by 3 over 5. Now 200 obviously times by 3 over 5, m would give me 120. So remember, with the multiplier, if it's inverse proportion, you just flip the fraction or flip the multiplier. So let's have a look at B. Alright, we know that k equals 600, and we're trying to find out what t is. So 746 equals 600 over t. T therefore would equal 600 over 746. I'm going to have to do that on a calculator. because I don't know that off the top of my head. That would give me t equaling 0.8 seconds. Alright, again, if you wanted to do it with the multiplier, you'd have 746 is to t as 200 is to 3. Alright, or if you want to write it the other way around, this might be easier. To t. So whatever we times 200 to get to 746, so let's times it by 746 over 200. That'll be easy. Then we then have to divide by 746 over 200, and if you did 3 divided by bracket 746 over 200 would give you an answer for t of 0.8. So exactly the same thing. Oh, yeah, because I've divided, that's fine. Okay. Now you'll notice, just before we go, that I've actually divided here instead of flip the fraction. Obviously, when you're dividing fractions, you flip it, it becomes a times anyway, so that's essentially the same thing. However, in the first one, I flip the fraction then times. It doesn't matter which way you do it, both ways should give you the correct answer. Okay, so here's a practice question I'd like you to have a go at. Please feel free to pause the video, and when you think you've got the answer, continue the video, and we'll see how you went. Okay, let's see how you went. So the question says the time taken to complete a certain job is inversely proportional to the number of workers. So the time is inversely proportional to 1 over the number of workers. Okay, or proportional inversely. If 20 workers complete the task in 6 days, how long would it take for 15 workers to complete the task? Now, I'm going to use the formula method. So t must equal k over n. Alright. If the time is 6 days and k over 20, then k must equal 120. How long would it take for 15 workers to complete the same task? So t must equal 120 over 15. Now 120 over 15, time must be 8 days. Okay. If you were going to use the multiplier method, alright, you'd go 6 is to 20 as t is to 15. Now here, we're obviously timesing by 0.75. So here, we're going to times by 4 over 3, or divide by 0.75. Alright, and that would, 0.75. That would give us an answer of 8 days.